Hi, my name is Farhan Hussein and welcome to School of Machine Learning. This is the first video in the course Introduction to Machine Learning with Python for Beginners. If you know some basic Python programming and want to get into the world of machine learning, well, this course is for you. The course is going to be available on this YouTube channel for free, but if you wanted to take it to the next level, which means quizzes, tests, coding exercises, machine learning projects, and obviously a certificate of completion, well, it is available on the schoolofmachinelearning.com website. You can go ahead and check it out right now. It is available there. Anyways, let's get started with the course. Welcome to the course Introduction to Machine Learning with Python. In this course, we are going to be taking a deeper dive into the fundamentals of machine learning. Let's take a look at these words, which you might have seen in many areas. These words are used almost interchangeably. Now, they are very similar to each other, but there is a slight distinction amongst them. See, the word artificial intelligence was actually coined in the 1950s, which meant as a simulation of human intelligence. Since the 1950s, a lot of things have changed. And this is where the word machine learning comes. The machine learning is basically the technical aspect of AI. And deep learning is basically the models that reside within the world of machine learning. So to put it simply, deep learning is a subset of machine learning, and machine learning is a subset of AI. Now, AI does not simply mean the technical aspect, because there are a lot of people, non-technical people, working within the world of AI, such as politicians and other regulators who want to regulate AI and a lot of other things. But for us, what matters is the word machine learning, and machine learning is basically the technical part of artificial intelligence. Now, let's take a look. What exactly is machine learning? Now, to understand what machine learning is, we need to look at an example and think of it in a traditional programming way. See, if we had to develop a program that detects what a cat looks like, we would explicitly write out the rules. We would say the cat is going to have 4 paws, it's going to have whiskers, it's going to have various other features of cat. Now, for one cat, you might be able to do it, but when things start becoming more complicated, when we start adding other animals and a lot of different things, well, no single programmer, or in fact, no company can actually build an entire such a system. And this is why we need something new. And this is where machine learning comes in. See, in machine learning, one of the major differentiators between traditional programming is that we don't explicitly tell it. We don't explicitly tell what to do. We say that, okay, here's data, and here's, in our example, a cat, here's how a cat is supposed to look like. Go ahead and make up your own rules. So to put it simply, machine learning is when computers try to find patterns from data and make smart guesses about new information. So keep in mind, the machine learning is we don't explicitly tell it what to do, but we let the system figure it out itself. Now, you might have seen in the world of machine learning, you might have seen things like chatbots, such as ChatGPT, but machine learning is used almost everywhere. From biology, in biology, machine learning is used in detecting of various cancer cells. In self-driving car, machine learning is used, and in agricultural, machine learning is used to predict the crop yield, and for solar systems, it's basically used for trying to maximize the efficiency. So machine learning is not specifically just related to specifically related to one aspect, but it's pretty much taking over all of the world. So this is why machine learning has become incredibly important in our lives. And in next video, we are going to be taking a look at what are some of the types of machine learning. Let's look at what are some of the types of machine learning. And machine learning has quite a few types, but the most popular ones, the 3 most popular ones, and the ones that we are going to be looking in the course are supervised learning, unsupervised learning, and reinforcement learning. And I'm pretty sure you might have at least heard about some of these words previously. So let's start off with the first one, and that is supervised learning. What exactly is supervised learning? Supervised learning, as the name suggests, it is like having a supervisor, and in this case it is going to be labeled data. The most important thing in supervised learning is the labeled data, and for this kind of machine learning, it's used for classifying and predicting new or unseen data. And some of the examples which are currently used are in our, for example, Google uses for in their Gmail, they use for detecting spam or not, and various other companies they use for predicting prices of houses and stocks and a lot of other things. And some of the popular algorithms for supervised learning are types of regression models, which we'll be looking at in our course. To get a better understanding of supervised learning, let's take a look at an example. Let's say in our case we have labeled data, and the labeled data in this case is pictures of cats and dogs, and with each picture we have an associated labeled data, that is cat and a dog. And then we have our model, our classification model, and then we train with this. So what happens when we pass on after the training is done? We start doing inference. Inference basically means prediction. Let's say the model has never seen these pictures, and this is a picture of a cat and this is a picture of a reptile. When we pass this on to our classification model, it is able to detect in supervised learning that this classification model is able to predict correctly that, okay, this picture is of a cat and this picture is not of a cat. Now, in this very simple example, we just looked at pictures of label data of cats, dogs, but in real world, it's going to have massive amounts of various other labeled data. So some of the most common algorithms within supervised learning are related to regression type models and classification type models, and these we'll be looking at in our course. Now let's take a look at unsupervised learning, and as the name suggests, unsupervised machine learning is not having a supervisor, or in this case not having labeled data. And as you can imagine, labeled data, it is very important. So in unsupervised machine learning, we try to find basically some patterns, some structure within the data on how we can classify or segment this type of data that does not have any associated labels with it. Now, in fact, the majority of how we learn in real life is also with kind of unsupervised machine learning. Basically, if you're trying to look at a game and trying to see how to play it without being explicitly told, you can just look at it and try to figure it out. So this is what unsupervised machine learning is. And some of the popular algorithms for unsupervised learning are k-means clustering, hierarchical clustering, and PCA. So let's take a look at an example to understand unsupervised machine learning better. Let's say that we have these 3 flowers. Now, the model does not know they are flowers. It has no associated data with it. But we want to kind of get some kind of characteristics out of these 3 flowers. So we say, okay, let's try to look at the number of pixels. So that's what the model is trying to do now. It's trying to look at, okay, the number, how many petals that each of these flower has. Again, keep in mind that there is no associated data with it. So then it segments them into saying that, okay, these 2 flowers, they have 6 petals, and this flower has 5 petals. This is all done without explicitly being told anything related to these flowers. So as you can imagine, the majority of things that we learn as humans, we do it through an unsupervised learning. So some of the most common algorithms out there, it's clustering and dimensionality reduction in the previous slide. Basically here, this is trying to cluster it, and something in real life, you would use something like a k-means clustering to find the number of petals and try to get an understanding of the data, of the structure within this data. So keep in mind that the major difference between unsupervised and supervised learning is basically to do with labeled data. Now let's take a look at reinforcement learning. The goal of reinforcement learning is basically to find the most optimum strategy. In reinforcement learning, strategy is called a policy to get the maximum reward. That is going to be our goal with the reinforcement learning. And we do this by interacting with an environment. So there's some very important concepts within reinforcement learning. That is a concept of environment, concept of an agent, state, and policy. So an agent takes an action in an environment, and that agent receives either a reward or a penalty. It's going to be positive or negative, and the agent performs these actions through a trial and error process. So it is an iterative process. And some of the most common examples of reinforcement learning is basically teaching a robot how to perform a certain task, or teaching an AI agent to play various video games. Some of the most common differences between supervised and unsupervised machine learning versus reinforcement learning is there is no explicit training data. It does this all by its trial and error. And some of the most popular algorithms are Q-learning, deep Q networks, and policy gradients. And if some of these words seem very confusing to you, don't worry. In this course, we are going to be taking a look at all of them. So let's see how reinforcement learning actually works. So in reinforcement learning, we have an agent. The agent performs an action in an environment. Then the environment is going to provide a positive or a negative feedback. And then the agent is going to adjust its policy, which is basically its strategy to increase its reward. As you can already see, it's quite different from supervised and unsupervised machine learning. So now let's take an example of how reinforcement works in the real world, basically trying to have an analogy here. So our goal is basically to teach the dog to fetch the ball whenever we issue the command fetch. In our case, the dog is going to be the agent, the yard is the environment, and the human is the reward function. And anytime the dog performs an action, it's going to be the state. So whenever we throw the ball and say fetch, and the dog goes and fetches it, we encourage it by giving it dog treats. So then over time, the dog is going to find the most optimal strategy through trial and error, just waiting for as soon as the human throws the ball and says fetch, to go and get the dog. And when we just throw the ball without saying the fetch, we do not give the dog a treat. So the dog knows, okay, the word fetch is associated with the treat. So this is how the dog learns it. So this is basically the analogy of a reinforcement learning. Now, reinforcement learning, some of the algorithms of reinforcement learning are very complicated, but don't worry, in this course we are going to be looking at them, and some of the very most complex ones we are going to be taking a look at in Introduction to Deep Learning. So make sure you check that course out in our homepage. So that was reinforcement learning. Let's kind of revise what we have learned so far within the types of machine learning. There in our course we are looking at three major types, and that is supervised machine learning and unsupervised machine learning. Both of these are associated with labeled and unlabeled data. And in reinforcement learning, we have an environment and an agent who performs an action within an environment. But there's more there. So even though, as I mentioned earlier, those are the three most popular ones, as with more advancements in machine learning, there are new types of machine learning that are coming out, such as self-supervised learning, multi-instance learning, transfer learning, and zero-shot learning. And if you guys are interested in this, I'll be providing more information about these in the notes section. Now, one question that you might have in mind is, what about machine learning applications such as ChatGPT? What kind of machine learning do they use? So in those cases, and in most popular machine learning applications, they use all types of machine learning applications. In fact, for ChatGPT, they use all three. It starts off with an unsupervised machine learning model, then it comes to supervised machine learning, and they finally have reinforcement learning with human feedback. So as you can see, they use all types of machine learning model. So in your mind, you should not be strict on, okay, I have to use one specific one or the other one I can't use. You have to just try to see which one is going to be the most optimal for your problem that you want to solve. So that was an overview of the types of machine learning. And in upcoming videos, we are finally going to deep dive into Python with machine learning.